morning, students. Today we'll have physics. And the topic we're discussing is speed and velocity. In this study, the instructional materials we're using here are Basic Physics for Senior Secondary Schools by P.N. Odume, New School Physics for Senior Secondary Schools by M.W. Anyakoha. Instructional objectives. At the end of this topic, the students should be able to 1. Distinguish between speed and velocity, plot a distance time graph, and deduce the speed of motion from the gradient or the slope of the graph. The concept of speed. When a body is in motion, the distance and the time it takes to cover that distance is noted. So from there, we want to now go into the definition of the term speed. Speed, we normally use V to represent it, is defined as a time rate of change of distance. We've said it here as it is in motion, the time it takes is considered. We are considering the speed, the distance covered, and also taking note of the time it has taken. This is given by the formula speed V is equal to distance covered by an object by the time taken to cover the distance. And we'll have the distance, we represent it here with S, and the time taken with what? Small t. So we have it that, symbolically we have it that speed is equal to V, speed is equal to S over t. Since distance is measured in meter and time is measured in seconds, the SI unit of speed is meter per second. You can still remember what we did in derived quantities and units. So we'll have the SI unit of speed here is meter per second. Speed is a scalar quantity since it has only magnitude. It doesn't have direction. So we'll call it a scalar what? Quantity. I hope you are following. Okay. Now we want to look at uniform speed. We have what is called uniform speed. And this is gotten when a body covers equal distance in equal time interval, no matter how small the time interval may be. For instance, if you have a distance of 100 meters and you divide it into 5 partitions, each is 20 meters. So the time taken also, if it is supposed to be equal time interval. So such speed there is known as uniform speed. We say it is gotten when a body covers equal distance in equal time interval, no matter how small the time interval may be. Or we can define it as it is gotten when the time rate of change of distance is constant. One can say that if you don't want to go in with this definition here, you can say that it is gotten when the time rate of change of distance is what? Constant. The next one is non-uniform speed. This is gotten when the distance covered with time by an object over a particular journey is not steady. It is not constant at all. As we go ahead, we'll use examples to explain them. Or it is gotten when the time rate of change of distance is not constant. For instance, you have it that for the one I've given you before now, if you have a distance of 100 meters and you still divide it into 5 partitions, 20 meters each. But the time taken there is not constant in each of those distances there. So in that one, you have it to be non-uniform speeds. This may be due to traffic conditions. Under a non-uniform speed situation, the distance covered by the object divided by the time taken is known as average speed. So like what I have here, non-uniform speed is always gotten due to traffic conditions. It could be you have potholes on the road, you have checkpoints. These are some of the things that may try to bring about non-uniform speeds. Now, so the distance covered by the object divided by the time taken is known as average what? Speed. So in this non-uniform speed, we'll now discuss what is called average speed. So in that one, you have total distance covered by the time taken. Because here we find out that the time taken is not the same because of traffic conditions. So we'll now go about finding this with average speed equal total distance covered by the time taken. Now we'll go over to what is called instantaneous speed. It is a speed covered by an object in a unit time, meaning in a short time what? Interval. So we'll say it's instantaneous at a particular instant. So the distance covered by an object in a unit time is known as instantaneous what? Speed. Now I want to look at the concept of velocity. The concept of what? Velocity. Recall that displacement is the distance covered by an object in a specified direction. Distance covered by an object in a specified what? Direction. We've done this before now. I will say, as for instance, a student moving out of the classroom without telling us where he or she has gone to. You've just covered ordinary distance. But once you now specify, I say, I want to go to the principal's office. Say distance covered by an object in a specified what? Direction. We'll call this what? Displacement. So for that reason, we'll have it that velocity is the time rate of change of displacement. And it is given by the formula velocity is equal to change of displacement over what? Time. So we'll have this as the definition of what? Velocity. The displacement now and then divided by the time you've taken to cover such displacement, we'll have it to be what? Velocity. And we'll still use the same symbol V for velocity as we use in that of speed. And then displacement, we use the symbol, the alphabet S, and time will have T. So for that reason, we'll have it also that the SI unit of displacement is meter, SI unit of time is what? Second. For that reason, the SI unit of velocity is meter per second. But in this one, it is a vector quantity. Speed, we said, is a scalar quantity. It doesn't have direction. But now in velocity, it is a vector quantity because the direction is specified. The example I gave is student moving to the office of the principal. The person specified his direction. So we say it's a vector quantity. It has both the distance inside it and the direction where the person is going to. So it's a vector quantity. Now go into uniform velocity. This is gotten when a body covers equal displacement in equal time interval, no matter how small the time interval may be. I gave you example in the other one. Person now moving to the principal's office. I have specified it. And for instance, the distance from your classroom to that place is 100 meters. Divided by 5, you have each 20 meters. Now, if that person covers each of the 20 meters distance by the same time interval, what the person has achieved there is known as uniform velocity. Is that okay? Okay. Or if you don't want to define it this way, you can simply put it to be that it is gotten when the time rate of change of displacement is what? Constant at each interval of the distance and the time there. And the distance covered there, or the displacement covered there is equal, and then the time taken there is what? Equal. So we say It is gotten when the time rate of change of displacement is what? Constant. The next is non-uniform velocity. This is when the time rate of change of displacement is not what? Constant. We have it there that the displacement there is the same. We have divided the distance there to be equal, but the time taken is not the same. It could be that as you are going there to that office, and someone may not send you to go to somewhere else, and you now change your direction. Or it could be that if you met a friend on the way, and you could not meet up with the time interval you have been maintaining. So in that one, you have the time rate of change of displacement there is not what? Constant. Is that clear? Okay, the next is instantaneous velocity. This is gotten when an object covers a particular distance in a specified direction within a short time interval, or within a unit time, like as we said in that of instantaneous speed. The only difference here is that direction is what? Specified. Now I want to see how we can solve some problems under speed and what? Velocity. The first example we have here says, if a bus covers a distance of 200 kilometers in 2 hours, calculate its average speed. So I want to see the board now for solution to this question. If you look at the question there, the distance given to you, the distance covered is equal to 200 kilometers. Now, kilometers is not the SI unit of distance, it's meters. So to convert, we multiply by 1,000. We'll have 200 times 1,000. It will now give you the value in meters, and that gives you 200,000 meters. Now, the time taken is 2 hours. But the SI unit of time is not in hours, it is in seconds. So I want to convert 2 hours to seconds. But 1 minute is equal to 60 seconds. And 60 minutes make 1 hour. Now if you now cross multiply here, we'll have 1 hour times 1 minute is equal to 60 minutes times 60 seconds. So minutes will cancel out minutes. We now have 1 hour times 1, that is 1 hour, equal to 60 times 60 seconds. That is what we have here. And the value will now be in seconds. So it will now give you 3,600 seconds. So the value of 1 hour is 3,600 seconds. Now, 2 hours will now be 2 times 3,600 seconds. For us to get the average speed now, we'll have total distance covered by the total time taken. And the total distance covered is 200,000 meters, which is here. Now, total time taken now is 2 times 3,600. Is what we have here. If you now divide, have 0 against 0, 0 against 0. Now, 2 here, 1, 2 into 200 will give you 100. Now, times 0, we'll have, 100 now, then what is not remaining here is 0. You now have 1,000 divided by what? 36. That is what is remaining here. So if you have 1,000 divided by 36, that gives you 27.777 meters per second. So that is approximately 27.78 meters per what? Second. We want to go to now example 2. Now example 2, a car which travels at an average speed of 800 kilometers per hour spends 2 hours to reach its destination. How far has it traveled? We want to go to the board also to see the solution to this question. Now we want to look at solution to example 2. In that question, you are given average speed equal to 800 kilometers per hour. That is 800 kilometers over 1 hour. Now, total time given to you there is 2 hours. But average speed is given by the formula total distance covered over total time taken. So if you make this just the formula from this equation, total distance is equal to average speed times total time taken. So from here we'll have average speed is 800 kilometers over 1 hour times 2 hours. So hour will cancel hour, now have 800 kilometers times 2. That gives you 1,600 kilometers. If you want to convert from kilometers to meters, we have said you multiply by 1,000. So if you have 1,600 times 1,000, so that gives you 1,600,000 meters. Now, example 3 says a car travels for 3 hours to a distant city 200 kilometers due east. Due east, meaning the direction is specified. Calculate its velocity. Now I want to look at the solution to question number 3. Now question you're asked to calculate the velocity. So we'll have it that velocity is given by the formula distance covered in a specified direction by an object by the time taken to cover such distance. So in that question you have the distance covered in a specified direction due east to be 200 kilometers. Then the time taken is 3 hours. So we'll have it there that 200 kilometers is 200 times 1,000 to give you the value in what? Meters. And to convert from hours to seconds, I've already calculated for the first example that 1 hour gives you 60 times 60 in seconds. Now by 3 hours, you now have 3 times 60 times what? 60. Is that okay? If you cancel now 0 against 0 here, 0 against 0 here, now left with 2,000 times 200 times 10. That gives you 2,000 divided by 3 times 6 times 6. That is what we have here. If you multiply this out, divide this by this value you have 2,000 over 108. And that gives you finally 18.52 meters per second. Now I want to look at distance time graphs. Meaning graph of distance plotted on the y-axis against time on the x-axis. So call it distance time graph. So we'll have different ones. We'll have distance time graph for a uniform speed. Now we'll have here as the y-axis, you now label it distance, and the unit of distance is meters. Make sure you label your axis. Now on the x-axis you have time, and the unit is what? Seconds. So we'll have it that it is always a straight line graph. I've told you the reason is a uniform speed graph. So we'll have it that it's always a straight line what? Graph. And for you to get the speed, you take a slope from the highest value of your distance, and then you have here also as your y1, the lowest value of your distance, and then your time taken change in time will give you the highest value of your time and the lowest value of your time, depending on where you're taking your points to be. So we'll have it already that speed is distance over what? Time. So our slope will now give you change in y or change in x. So in your change in y, you have y2, that's the highest value here, minus what? Y1. Now you have for change in x, you have x2 minus what? X1. So this will now give you change in x. And once you calculate this, you have gotten the speeds. So as we use examples ahead, we're able to understand this better. Now the next is distance time graph for non-uniform speed. Non-uniform what? Speed. Now we'll have also y-axis labeled distance in meters, and then x-axis labeled time in what? Seconds. It is not a straight line graph because the time interval is not what? The same. So for that reason, you have such a graph. Then if you take the slope, you can still get the value of your what? Speed. As we go ahead with examples, you understand it better also. Now we'll have the next one will give you displacement time what? Graphs. Under this, we'll have it that displacement is plotted on the y-axis against time on the what? X-axis. So we'll have the first one as displacement time graph for uniform what? Velocity. Now, it's always a straight line graph as that of a uniform speed. So you'll still get your velocity by having displacement over time, which is the formula, and then your slope will still give you y2 minus y1 over x2 minus x2, which if you calculate will give you the velocity of this motion. Now the next is displacement time graph for non-uniform speed. The first one was for uniform speed. Then we'll have also on the y-axis displacement in meters. Then you have on the x-axis time in seconds. I've told you for non-uniform, either speed or velocity, the graph is not a straight line what? Graph. So we'll still have velocity, which is equal to displacement over time. And then the slope for you to get this velocity will give you change in y over change in s, which is y to the highest value of your y and the lowest value of your y, the highest value of your x-axis, and then the lowest value of your x-axis. So the values you have taken with this right angle triangle will give you the slope, and the slope, once you calculate it, gives you also the word velocity. Now I want to prove these graphs we've shown above. So we'll have proofs of the graphs. Example 1. I want to use values now to prove these graphs. Plot a graph of distance against time and determine the speed from the table below. So we'll have the distance in meters and time in seconds. The value of the distance in meters will have 100, 80, 60, 40, 20, and 0. So the intervals here are what you have. Within the intervals, you have equal values. And the value here is what? 20 meters each. So for the time, you have 6, 5, 4, 3, 2, 1. Interval here of 1 second each. So it's a uniform speed. So here is what you have here is uniform speed. If you divide in each of the distance, the difference you have here, what you're going to get here is a uniform speed. So I want to use this table to see how the graph will look like. We'll have these values is for the distance. You have 100, you have 80, 60, 40, 20, 0. Now you have the time. You have 1, 2, 3, 4, 5, 6. That is what you have on the table there. Now we'll have it that at 20 meters, the time there is what? 2 seconds. So at 20 meters, the time is what? 2 seconds. Now from your table, when you have 40 meters, the time is 3 seconds. So you watch it. At 40 meters, the time is what? 3 seconds. At 60 meters, the time is what? 4 seconds. At 60 here, 60 on the y-axis, you trace the points, the time is what? 4 seconds. So at 80 meters, the time is what? 5 seconds. We have at 80, the time is what? 5 seconds. And finally, at 100 meters, which you have on the table there, the time is what? 6 seconds. If you trace the points now and join them, you have a straight line what? Graph. You can take your slope from any of these points. So if we're taking the slope from this 100 here as against 20, and then we're taking this point now, you have it that for you to get the speed, our speed is distance over what? Time. And we'll have it that taking the slope to get the speed, we'll have change in y over change in x. That gives you your y2 minus y1, what we have said, x2 minus x1. And your y2 here, the highest value of your y as we're taking the slope, is 100. And the least value you have here is what? 20. All over the highest value of your time, according to this slope you have here, is 6, minus the least value, the lowest value you have here, according to your slope, is what? 2. And 100 minus 20 gives you 80, and 6 minus 2 gives you what? 4. And 80 divided by 4 gives you what? 20 meters per what? Second. So this gives you now the speed of that graph. Is that okay? So you can take your slope at any point. It can be even at 80 as against 20, or even 100 as against what? 40. If you check it, you will still get the same what? Answer. Is that okay? We have example 2. Plot a graph of distance against time and determine the speed from the table below. We still have distance in meters and time in what? Seconds. To tell you its distance time graph. Now we have the distance covered. We have 0, 2, 4, 6, 8, 10. Here you have them to be uniform, equal interval. But in the time intervals, it's not the same. We have 1, 3, 6, 4, 7, 9. So it's not the same. So this is going to give us a graph of non-uniform what? Speeds. So this is the graph of that table. In that table, you have it that here we'll have on the y-axis, you have distance labeled here on the y-axis, and then you have time on the what? X-axis. Is that okay? Now I want to trace out the values from the table. Now at 0, when the distance is 0, the time taken is 1 second. So at 0, you have it to be at what? 1 second, 1 second here. Then the next one, when the distance is 2 meters, the time is 3 seconds. 2 meters is against what? 3 seconds. The next one is 4 meters is against 6 seconds. 4 meters. 4 meters is against what? 6 seconds. Now 6 meters is against 4 seconds. 6 meters, have it here, is against 4 what? Seconds. Now the next is 8 meters, is against 7 seconds. 8 meters here, you stress the point where you have 7, you have it here. Is that okay? So here is where you have 8 meters is against 7 seconds. The last one is 10 meters is against 9 seconds. I have 10 meters, you trace the point, you have it here. If you have your graph book, you can check this later. It's 10 meters as against what? 9 seconds. If you now join the points together, you have this join to here, join to this point. So this will not give you a straight line graph. The particular instance here, you can take this loop. So we'll have here, if you draw a tangent here, you can now get the slope of this non-uniform speeds, such that from here you can trace the point we'll have here to be your y2. Your y2 here gives you 8 meters. Then the least value of this, the lowest value of this, you have 2 meters. So we have 8 minus 2 as to represent y2 minus y1. Then for your time interval, this point here, you trace it down to this point. You have here as x2, which is 8 seconds. Then you trace this point down here, which is supposed to be what? 5 seconds. So we have 8 minus 2 is equal to 6. 8 minus 5 is equal to what? 3. So here it gives you 2 meters per second. That gives you the non-uniform speed of this graph. Evaluation. We want to see whether you are able to get what we discussed in this topic. The first one, it says state two differences between speed and velocity. state two differences between speed and what? Velocity. Number 2, a boy cycles continuously through a distance of 1,000 meters in 5 minutes. What is the average speed of the boy? So I want you to work on this. I believe you must have finished writing by now. You can mark for yourselves. Before you mark for yourselves, we want to look at the solution to what you have here to know what it corresponds with what you've written down. Now, solution to number 1, you're asked to give two differences between speed and velocity. The first one, speed is the time rate of change of what? Distance. While velocity is the time rate of change of what? Displacement. We're using definition here to differentiate them. Speed is a scalar quantity, while velocity is a vector quantity. If that is what you've written down, you can mark good for yourself. Solution to number 2. That question distance is 1,000 meters, and the time given to you is 5 minutes. And 5 minutes will now give you in seconds. It will be 5 times 60 seconds to give you 300 what? Seconds. So the average speed here gives you total distance covered by the object over time, total time what? Taken. So if you subtract the value, you have 1,000 here as I get the total distance covered, while the time taken is what? 300 seconds now. If you divide this by this, you have 3.33 meters per second. Is that what you've gotten? That is good. So we've come to the end of this lesson today. So we'll see next time we'll have you. Thank you very much.